morning to all. In the previous lectures, we discussed about the classification of filters where based on the impulse response, we can categorize the filters as FIR filter and IR filter. In this video, we mainly concentrate on FIR filters and have a small comparison with the IR filter also. Okay, what is FIR filter? FIR filter, that is as the name indicating, FIR stands for finite impulse response filter. Okay, that means the filter coefficient, number of filter coefficient must be a finite value. Okay, that means the filter duration is a finite quantity. That's why we call it as finite impulse response filter. And we can say that FIR filter is always a stable. It is a stable filter and it is non-recursive type. The FIR filter is also known as non-recursive filter. What is the reason? Because in the case of FIR filter, the output of the filter depends only on present and past values of the input. That's why we call it as non-recursive. The output of the filter, it depends only on the present and past values of the input. Okay, we can check it here. We know that the output of the filter can be represented as y of n is equal to x of n convolution h of n. Using commutative property, we can say that it is similar to h of n convolution x of n. Okay, in mathematically, we can represent y of n as this, the expression. Mathematically, h of n convolution x of n can be represented as summation over k varies from 0 to capital N minus 1 h of k into x of n minus k, where capital N is the length of the filter. Okay, it represents the number of filter coefficient, capital N. Okay, then substitute the values, you will get first term h of 0 into x of n. X of n stands for the present input. X of n is the present input because we consider at the nth time instant. Okay, the output at the nth time instant, small n. So the x of n is the present input. Then substitute the remaining values, you will get h of 1 into x of n minus 1. The values are x of n minus 1. So expression, check the expression, x of n minus 1, x of n minus 2, like that. Okay, these are the past input. So we can say that the present output depend on present input and the past inputs. That's why we call it as non-recursive type filter. Okay, that's why we named it as non-recursive. It is not depend on past output. Not depend on past output. Here, there is no past output. So there is no feedback is required in the case of FIR filter. Then we can compare with IR filter, a small comparison. Okay, IR filter stands for infinite impulse response. Infinite impulse response. That means the duration is infinite and we have many coefficients. And here, in the case of IR filter, it is a recursive type. Recursive type means the present output of the filter, it depends on present input, past input and past output. It depends on past output also. Okay, recursive, that's why we call it as recursive type. That means there is a feedback is present. It depends on present input, past input and past output also. So there is a requirement of feedback and it is called a recursive filter. And we have infinite coefficient. That's why we call it as infinite impulse response. Okay, we will discuss about IR filter later. Okay, here we discuss mainly concentrate on FIR filter. Then another property of FIR filter is that it is a linear phase. What is a linear phase? If we plot the phase response of the FIR filter, it is linearly proportional to the frequency. That's why we call it as linear phase. We know that the frequency response of the filter can be denoted as h of omega and mod equal to modulus of h of omega into angle of h of omega. And this is the magnitude term and this one is the phase term. And angle of h of omega is let it be represented as theta of omega. Okay, here we said that FIR filter is a linear phase filter. That means its phase response is proportional to frequency. That means phase response theta of omega is proportional to frequency. That's why we call it as linear phase filter. Okay, if we plot the response, frequency response, we can say that if we consider this figure, okay, it's taken as just an example. Here, if we check it, the frequency response. Here we plot the frequency response with respect to frequency omega. Here, the phase response plotted with respect to frequency. The phase response is a linear with the frequency. So that's why we call it as linear phase.